Hi class, this is Neil, and this is the second video on Unit 9, Lesson 1, a review of trig ratios and what we learned about right triangle trigonometry in geometry. So what you learned about really in the ninth grade year. This corresponds to page 2 of the handout, and we'll be looking both at notes for trig ratios. We'll look at practice problem 1 and practice problem 3. You'll have to do on your own practice problems 2 and 4. And then we'll also look at how to find a missing side when we know one angle of a right triangle. All right, so I'm going to transition to the slideshow. So the three trig ratios that we're working with are sine, cosine, and tangent. So if we're given an angle of a triangle, and let's say that A is equal to our angle, then sine, or sine of A, is equal to the opposite side over the hypotenuse. So it's the ratio of the opposite side to the hypotenuse. Cosine of A is the same as the adjacent side to the hypotenuse. And tangent of A is a ratio that compares the opposite side to the adjacent side. So in geometry, you probably learned that there's a easy way for us to kind of remember what these three ratios are, and that's SOHCAHTOA. So S stands for sine, meaning opposite over hypotenuse. C standing for cosine, is adjacent over hypotenuse, and tangent stands for opposite over adjacent. So that's an easy acronym we can use to remember those three ratios, sine, cosine, and tangent. You can pause the video here if you need to. All right, so we're going to look at how we would use this in practice problems 1 and 3. So in practice problem 1, we're really just asked to write the ratios for sine, cosine, and tangent for angle B. So the first thing I would do in practice problem 1 is I would really want to label my triangle like you did in the first video, or like we did in the first video. So I'll circle angle B. I'll draw a line across to the opposite side, which is 24, but I'll go ahead and label that as opposite. I'll draw a line opposite the right angle to identify the hypotenuse. And finally, the adjacent side is the side that I'm left with here. So because sine compares the opposite to the hypotenuse, I'll just write those side lengths as that ratio. So 24 over 25. For cosine, cosine of B is the ratio of the adjacent side to the hypotenuse. So I'll just write in the side lengths for those two sides, 7 over 25. And tangent now is the ratio of the opposite side to the adjacent. So I'll just write in those side lengths, 24 over 7. All right, so what you should work on is practice problem 2. You can pause the video, take a minute to answer question 2 on your own paper or on the worksheet if you were able to print it out. All right, so in practice problem 3, we're told that in right triangle SAT, shown below, the tangent of S is equal to 4 over 3. And we're asked to write a ratio that represents cosine of S. Well, I'm just going to write down what I already know. I know the tangent of S is equal to 4 over 3. And I'm going to remind myself that tangent is the ratio of the opposite side to the adjacent. Now, I know I'm dealing with angle S here, so I'm going to label triangle SAT given that S is my specified angle. Okay, so 4 is the opposite side of S. So 4 is my opposite side. 3 is the side that is not the hypotenuse, so that's my adjacent side length. And now what I'm looking for is the length of my hypotenuse. So the question really is, do we know a way to calculate a missing side length in a right triangle? And we do. My missing side length here is side ST. I'm just going to define that as side X. And now what should come to mind is the Pythagorean theorem. A squared plus B squared equals C squared. So I'll just plug in what I know. So A is 3, B is 4, and I'm looking for my hypotenuse. So one thing I didn't mention, but sort of it's something that we should look at, is that C here is always the length of the hypotenuse. It doesn't really matter what you define as A and B, but you do need to be clear that whatever you say side C is, that has to be your hypotenuse. All right, simplifying that equation, we would get 9 plus 16, or 25, is equal to x squared. Take the square root of both sides to solve for x. And now x equals 5. Okay, but I'm not done, because I do need to now use that information to help me write the ratio of cosine of s. So x is my hypotenuse. Cosine of s, remember, is my adjacent side, which is 3, to my hypotenuse, which is 5. So cosine of s is 3 over 5. All right, so that's practice problem 3. On your own, I want you to do practice problem 4. What I would suggest you do first is draw a triangle. My triangle here is hopefully not, it's not the best example. Why don't I erase that and start over? So what I would suggest you do to start is draw a triangle, ABC. Let's just call that A, B, C. And now remember, cosine of A is equal to the opposite. Is that right? No, it's not. Cosine of A is equal to the adjacent over the hypotenuse. So that's enough to get you started. You should go back and look at the notes for that problem. All right, so that was practice problem 3. All right, so that's the end of this video, and we will look next at how to find a missing side length in the next video.